Welcome students to my channel GS Maths once again. Today I am going to start with a new chapter from class 10, that is the chapter of triangles. It's a very important chapter, right? So from that very chapter I am going to start off basic proportionality theorem, or the second name of it is Thales theorem. We call it as Thales theorem also. Thales theorem and its applications. I will do few questions which apply this theorem, right? Now let us start off with basic proportionality theorem, its statement and proof. Now let me draw a triangle first. This is a triangle ABC, ABC, right? Then a line which intersects the two sides AB and AC in two distinct points D and E, and DE is parallel to BC, then AD upon DB is equal to AE upon EC. This we have to prove. Now the statement says if we draw a line parallel to one side of the triangle to intersect the other two sides in two distinct points, right? In two distinct means different points, D and E. Then the two sides are divided into same ratio, that is AD upon DB is equal to AE upon EC. This is the statement of the basic proportionality theorem or Thales theorem. I again repeat, if we draw a line parallel to any one of the side of the triangle, in our case DE is drawn parallel to BC, it's given to us. Okay, DE is drawn parallel to BC, then intersecting the other two sides in two distinct points, then the two sides, these two sides AB and AC, they are in the same ratio, they are divided into same ratio, that is AD upon DB is equal to AE upon EC. This is the statement of basic proportionality theorem. Now how to prove it? Prove is, first of all, join BE and CD. Join BE and CD. I've joined. Now draw perpendicular EM and DN like this. EM is perpendicular to AD, EM perpendicular to AD, and DN perpendicular to AE like this. This is the construction part which we have to do. Join BE and CD, then drop EM perpendicular to AD and DN perpendicular to AE. Now, area triangle ADE, it is half into base, base is AD, into the height, height is EM, like this, half base into height, base is AD, the height of the perpendicular is EM. And now area triangle BDE, BDE, it's again the same formula, half base, base is BD and perpendicular drop on the extended BD is EM, half into base into height. Now when we divide these, we get the ratio area triangle ADE upon area triangle BDE. This is equal to half with half goes, EM with EM cancels, it is AD upon BD. This is our first equation. Now the second case is, again I take area triangle ADE. This can be written as half into, now I will take the base as AE and the perpendicular DN, half base into DN. This is the height. Then area triangle CDE now. It's half into base is CE, into the perpendicular drop, that is DN. DN is dropped on CE, extended, right? It is dropped DN on CE. The base remains CE because I am talking about the triangle CDE, or you can call CED, like this. Half into base into height. Height is DN. Now again, if I divide these two, I get the ratio of area triangle ADE upon area triangle CDE. This is equal to half with half goes, DN with DN goes, AE upon CE. This is second. Now from first and second, what I will prove, look here. Now area triangle BDE, this is equal to area triangle CED. Reason, because they are on the same base. Base is DE, and between same parallels. Between the same parallels DE and BC. DE and BC. This is the reason. This was the theorem which we have already studied in 9th standard. That is, area of the triangles which are between the same parallels and on the same base, they are equal in area. Now if these two areas are equal, area triangle AD upon area triangle BD, I can write here area triangle CD from this. So if I write down, that means from first and second, the left hand sides will become equal, therefore the right hand sides are also equal. AD upon BD is equal to AE upon CE. Hence, the statement is proved. That is, the basic proportionality theorem is proved. I again repeat the thing. ABC is a triangle. I draw DE parallel to BC, intersecting these two sides into distance point D and E. Now what I do is join these BE and CD, draw PN perpendicular on AD, DN perpendicular on AE. Take the areas, take their ratio, I get AD upon BD. Similarly, take the triangle AD and CED. Take their ratios, I get the second. From first and second, this left hand side equals to this left hand side. Why? Because area triangle BDE is equal to area triangle CD. The reason being, they are on the same base DE and between same parallels DE and BC. From first and second, I get the required result that proves my basic proportionality theorem. Now, it's converse. What is the statement of the converse of basic proportionality theorem? It's just, this is given to us, we have to prove that DE is parallel to BC. This is the statement of the converse of basic proportionality theorem. Let me write down the statement of converse of basic proportionality theorem. Now it's converse. Triangle is there, ABC. Now, DE. What is given to us? This will be given. AD upon DB is equal to AE upon EC. This will be given. So we have to prove that DE is parallel to BC. This is to prove. This is the statement of the converse of basic proportionality theorem. If the two sides of a triangle are in the same ratio, that is AD upon DB must be equal to AE upon EC, then DE is parallel to BC. This is converse of the basic proportionality theorem. Now these theorems, basic proportionality theorem and its inverse, we will use in solving problem sums. Let us start with solving of the numerical problems based on basic proportionality theorem. The very first question is, if a line intersects AB and AC of triangle ABC, let me draw a triangle ABC. If a line is drawn to intersect at points D and E, right? If a line intersects AB and AC of a triangle ABC at D and E respectively and is parallel to BC, this is given. DE is parallel to BC. This is given, right? To prove the AD upon AB is equal to AE upon AC. This we have to prove. Now, how to prove it? Make use of basic proportionality theorem. It is given. Prove is DE is parallel to BC. This is given to us. Now, using basic proportionality theorem, AD upon DB is equal to AE upon EC. This is by BPT theorem. We are using Thales theorem. The ratios AD upon DB is equal to AE upon EC. Now just take the reciprocals. Taking reciprocals. Now it becomes DB upon AD is equal to AE upon EC. Is it okay? Now adding 1 on both sides. Let me write over here. DB upon AD is equal to AE upon EC. Adding 1 on both sides. Add 1 on both sides. When I add 1, I get DB upon AD plus 1, AE upon EC plus 1. Now take the LCM, I get DB plus AD upon AD is equal to AE plus EC upon EC. That is DB, right? Plus AD, it is AB. I have to write it as AB upon AD. This is equal to AE plus EC. This is AC upon EC. Right? Now I wanted to prove AD upon AB is equal to AE plus EC is AC and this is EC. It should be, take the reciprocals. AD upon AB is equal to EC upon AC. This is EC. Yes. AD upon AB is EC upon AC or AE, I can say. If I take the reciprocals, it's DB upon AD, right? And it's EC upon, let me correct it. This was okay. It was AE upon EC. We have to prove AD upon AB equals to AE upon AC. AE. Taking their reciprocals, reciprocate both sides. It is EC upon AE. Now add 1 to both sides. AEC this was there, EC taking reciprocals. The reciprocal means take reciprocals on both sides. It becomes EC upon AE. That is AE. Now it becomes EC plus AE divided by AE. This is again AE. What I get is, now let me correct it. DB plus AD divided by AD. What is AE plus EC? This is AC upon AE. Just take the reciprocals, we get the result. AD upon AB is equal to AE upon AC. This is the result now. Now what I have done, I will again repeat. DE is parallel to BC. This is given to us using basic proportionality theorem. AD upon DB is equal to AE upon EC. Take their reciprocals. Reciprocals should be, what I did is I took the reciprocal of this side only. No, it was wrong. Just take the reciprocal of both the sides, then add 1 on both sides. You take the LCM. What is DB plus AD? DB plus AD is AB. What is AE plus EC? This is AC. I get the result. Just take their reciprocals now to prove the result. What we have to prove. That is AD upon AB equals to AE upon EC. This is one of the applications of basic proportionality theorem. Now the second question which we are going to do is again a very interesting one, and it's a direct application of basic proportionality theorem. Once again I am saying it's a very important chapter from examination point of view. That is, quite a number of questions are asked from this chapter in your CBSE board paper. Right? Now the second question says ABCD is a trapezium with AB parallel to DC. Let me draw a trapezium. That is ABCD is trapezium. AB parallel to DC. AB parallel to DC. This is given, right? E and F are points on two non-parallel sides. Let me draw the figure directly. It is like this. This is A, B, C and D. It is given to us, and it is given A, B, C, D is a trapezium. Now E and F are the points on non-parallel sides. E is a point on this side, F is point on this side. These are non-parallel sides, AD and BC, right? Such that EF is parallel to AB. This is also given. EF is parallel to AB. EF is parallel to AB. Show that, this we have to prove. Show that, let me join this. EF is parallel to AB. This is given to us. Show that AE upon ED, AE upon ED is equal to BF upon FC. BF upon FC. Now, for this, we have to join CA. Now, proof is join CA so that it intersects EF at a point G, right? Join CA to intersect EF at G. Now I take this triangle and the bigger triangle. Now triangle, it is given, let me start off. EF is parallel to AB, but AB is parallel to DC. It is given to us. Moreover, here A, B, C, D is a trapezium, opposite sides are parallel to each other. Now if EF is parallel to AB and AB is parallel to DC, therefore EF is also parallel to DC. EF is parallel to BC. Now, are joined CA to intersect EF at point G. Now take the triangles triangle AEG, right, and ADC. EG is parallel to DC, right? So we can use basic proportionality theorem, that is AE upon ED is equal to AG upon GC. This is again using basic proportionality theorem. That is, EG is parallel to AB because EF is parallel to AB, EF is parallel to DC. So part of it is parallel to AB. That is, EG is also parallel to AB. So we applied basic proportionality theorem to this. Now, this is your number one. Right? Now again, taking triangles, this triangle and the bigger triangle. That is, taking triangles. Triangle is CFG and CBA, like this. Again, GF is parallel to AB. GF parallel to AB. So take the ratios. That is CF upon FB is equal to CG upon GA. CG upon GA. Right? Now, just take the reciprocals. Taking reciprocals. I get FB upon CF is equal to GA upon CG. This is your second. Again, I've used what? Basic proportionality theorem over here. So from first and second, it is clear AE upon ED is equal to FB upon FC. From first and second, AE upon ED is equal to BF upon CF. Hence proved. This is the second application. This is again a very easy question. ABCD was a trapezium. It was given EF parallel to AB. Or if EF is parallel to AB, then EF is parallel to DC also, because these opposite sides of a trapezium are parallel. So starting from here, I took AEG triangle and ADC triangle, applying basic proportionality theorem. Similarly, I took CFG and CBA triangle. Again, I applied basic proportionality theorem. Just took the reciprocals. The one side, that is the right hand sides, were same. So the left hand sides are also equal. That is, A upon ED becomes equal to FB upon CF. This was the second application. This was application of basic proportionality theorem. If a line is drawn parallel to any one side of the triangle, it intersects the other two sides at two distinct points, then the two sides of the triangle are in the same ratio. It divides the other two sides of a triangle in the same ratio. This was the statement of basic proportionality theorem. Now, one more question. It's again a very easy question. Question says, question number 3rd. Question is, ABC are points on OP, OQ and OR respectively such that AB parallel to PQR. Triangle is PQR. It's like this. PQR Q, R. There is a point O like this, and this. This is point O. Now what is written is A, B, C are points on this. A is a point here, B is a point on OQ, C is a point on OR. Now if I join this, I get AB, I get BC, and I get AC. It is also given AB parallel to PQ, BC parallel to QR, and CA parallel to PR. This thing is given to us. Now what we are to show is, now these two things are given, these are given to us, so we have to prove that BC is parallel to QR. BC is parallel to QR. Now it's again very simple sum. AB parallel to PQ, right? This is your first case. AB is parallel to PQ means in triangles OAB, this triangle, and the bigger triangle OPQ, AB parallel to PQ, AB is parallel to PQ, therefore OA upon AP is equal to OB upon BQ. AB is parallel to PQ, AB is parallel to PQ, so OA upon AB, AP, OB upon BQ, they are equal to each other. This is our number one. Now, in second case, AC is parallel to PR, AC parallel to PR. This is given. Now I take this triangle, triangles OAC and triangle OPR. OC upon CR is equal to OA upon AP. This is our second equation. Now OA upon AP equals to this, OA upon AP equals to this also. So from first and second, I get OB upon BQ is equal to OC upon CR. OB upon BQ is equal to OC upon CR, which means what? It is BC is parallel to QR. BC is parallel to QR. This is nothing but it is a converse of basic proportionality theorem. This is the case of the converse of basic proportionality theorem. It is given the ratios, the ratio of the sides of the two triangles, they are same, then we say that BC becomes parallel to QR. These were the triangles there, OBC and OQR. We have proved that OB upon BQ equals to OC upon CR. Therefore, it proves that BC is parallel to QR. This was the application of converse of basic proportionality theorem, which I have explained you. One more question before we wind up this topic of basic proportionality theorem, its converse and its applications. Now, the question is this. ABCD is a trapezium again. This is A, B, C, D is a trapezium. It's given to us in which AB is parallel to BC and its diagonals intersect each other at point O. Okay, let me draw the diagonals. the diagonals they intersect at point O, show that AO upon BO is equal to CO upon DO. Now this we have to prove. It is given ABCD is a trapezium. ABCD is trapezium, right? The AB is parallel to DC. This thing we are sure. We have to prove AO upon BO equals to CO upon DO. Now how to prove it? Now in triangle ADC, now what we are going to do is, construction part is, draw a line OE, right? Construction is OE parallel to AB. Now if OE is parallel to AB, then it is also parallel to DC. Why? Because AB is parallel to DC, which means OE is again parallel to DC, right? Because it's a trapezium. The opposite sides are parallel. AB is parallel to DC. If we draw anything parallel to AB, then it automatically becomes parallel to the other side of the trapezium. Now, in triangle ADC, right? OE is parallel to what? DC. So take the ratios. Ratios are AO upon CO is equal to AE upon DE. This is by again basic proportionality theorem. That is AO upon OC, right, equals to AE upon ED or DE. Why? Because OE is parallel to AB or OE is parallel to DC. I have taken this triangle ADC first. Now take the triangle DBA. This is in triangle DBA. So in triangle DBA, OE is parallel to AB. This is DBA. Now I am taking this triangle. OE is parallel to AB, right? So take the ratio again. That is AE upon, that is DE upon AE, DE upon AE. This is DE upon AE is equal to OD upon OB, OD upon OB, right? Now just take the reciprocals. Taking reciprocals. If we take the reciprocals, what happens? It will be AE upon DE is equal to OB upon OD. Let this be second. This is your first. From first and second, both are equal to each other. This is AE upon DE. This is AE upon DE. So from first and second, we get AO upon CO is equal to OB upon OD. What we have to prove is OA upon OB, just adjust the terms. OA upon OB is equal to OC upon OD. Hence it is proved. These were few applications of basic proportionality theorem and its converts, right, which we proved. We first proved the basic proportionality theorem and its statement. Then we studied the converts of basic proportionality theorem. Then we did few questions based on these, that is basic proportionality theorem and its converts. I hope you have understood the topic. Just revise it. Just do the basic proportionality theorem, its proof, read the statement, right, and do few more questions from this, so that it becomes very easy. The concept of this becomes very clear to you. Thank you for watching my video. If you haven't subscribed my channel, please subscribe it. Thank you. Have a nice day.